Okay, as the title of this video suggests, it's all about using a force extension graph to calculate the work done by a spring under load. If we take a look at our specification here, okay, so this is the section we're working on. This is the section that the previous video dealt with. If we look at the next statement, it says here in bold, which means it's the higher tier, although a little bit confusingly, this bit's not in bold, so we need to cover it just in case. The work done in stretching by finding the area under a force extension graph. Okay, so the formula is work done is half force times extension. Okay, so if we just transfer that over onto here, so the work done by a spring is half of the force exerted on it times the extension caused by that. Now, I just want to compare this equation to one that you're familiar with in maths, and that is the area of a triangle, because this equation only works if the extension of the spring is linear. In other words, it's a straight line. So I'll come back to that in a second. But the area of a triangle in your maths lessons is area is half base times the height. Okay, mathematically it doesn't matter if that's if we just change that to half height times base. Okay, it comes to the same thing. And the reason I've done that is because I want to now compare that to our graph. So I'll just move this out of the way for a second. So this is our graph that we've previously been working on, finding the force using the extension, sorry, the gradient rather, the spring constant. So if we put a new triangle on here, okay, so this graph is for the linear extension of a spring, because these lines are all nice straight lines. Okay, they all fit the data perfectly. You'll notice that if I do that, I end up with a triangle. Now, if this was a maths exam and you were simply asked to work out the area of this triangle, then you would be using the area is half the height times the base. Okay, but this is not maths, this is physics. So we need to work out the area under this triangle, which is the work done. So we use the formula, sorry, W for work done, not F. W equals half Fx. Okay, so if we have a look at what that means, the F, force, okay, is the value on this axis here. Remember, this is the force, and we need to know the value of the force represented by this line. Okay, so if we just put a parallel line back along the graph to the force axis, and we find that the force that was needed to cause this extension is 1.8 newtons. Okay, so 1.8 newtons, and that value there is the height of this triangle. Okay, so we're looking basically for the height of the triangle, which is the force, and then the other value we need is the extension. The extension is represented by the value along here, and we can see here that the extension is 60 centimeters. Now, what we need to remember, though, is that any distance values for this topic need to be converted into meters. Okay, so 60 centimeters, I'm sure you're aware, is the same as 0.6 meters. Okay, so this is 0.6 meters. And again, as if we were comparing this to a maths equation, this is the base of the triangle. Okay, so it's equivalent, so x is equivalent to the base. So all we're doing with this formula is we're applying that formula there, which you're familiar with in maths, to find the area of this triangle. So the area of the triangle is the work done. Okay, so if we actually plug those numbers into our formula, so it's a half times the force, which is 1.8. We don't need to convert that because it's already in newtons, times the extension, which is 0.6 meters. Okay, we've got to convert that because everything has to be in meters. And if we put that into the calculator. We'll get, I'll just cancel that one there. Where are we now? Cancel. So a half is the same as 0.5. So 0.5 times 1.8. 1.8 times 0.6. So 0.6. That gives us 0.54 newtons. Not newtons, my apologies, joules, because work done is energy, and energy is measured in joules. Okay, so what I'd like you to do now is to pick 2 more of these lines and calculate the work done by the spring using the same method. Don't do it on the graph, okay? Do it in your book on the next page to show and make sure that you label each one accordingly so we know which spring you calculated the work done for. Okay.